Welcome back to RoboExpert. In this tutorial, we will build a web-based relay control system using the ESP32. This project is ideal for IoT home automation, allowing remote control of electrical appliances. We will cover the following key aspects: setting up the ESP32 as a Wi-Fi access point, hosting a web server with a user-friendly interface, adding basic authentication for security, using EEPROM to save relay states even after a power reset, implementing push-button controls for manual operation. By the end of this video, you will have a fully functional web-based relay control system that retains its state even after a power failure. Let's get started. An ESP32 development board, a 4-channel relay module, 4 push buttons, jumper wires and a breadboard, a 5-volt power supply for the relay module. To make this project small and compact, here I am using my designed home automation PCB. The ESP32 will act as a Wi-Fi access point and host a web server. The relays will be controlled both via the web interface and push buttons. The state of each relay will be saved in EEPROM, ensuring persistence after a reset. The relay module is connected to the ESP32 as follows: Relay 1 to GPIO 23, Relay 2 to GPIO 22, Relay 3 to GPIO 21, Relay 4 to GPIO 19. The push buttons are connected as follows: Button 1 to GPIO 34, Button 2 to GPIO 35, Button 3 to GPIO 32, Button 4 to GPIO 33. The ESP32 will be powered via USB, while the relay module requires a 5-volt power source. Make sure all ground connections are common. Open the Arduino IDE and start by including the necessary libraries. The Wi-Fi library allows the ESP32 to create a wireless access point. The web server library helps in hosting the web interface. The EEPROM library is used to store the relay states. Next, define the Wi-Fi credentials and assign a static IP address. This sets up the ESP32 as a wireless access point with the IP address 192.168.4.1. Now define the relay and button pins along with the EEPROM size. The relay states will be stored in an array and later saved in EEPROM. In the setup function, initialize the EEPROM, configure the relays, and restore the saved relay states. This function ensures that the relay states are restored from EEPROM, sets up the Wi-Fi access point, and starts the web server. To secure the web interface, add basic authentication. Users must enter the correct username and password to access the web page. Now define the web server routes and apply authentication to them. Each relay can be toggled via a unique URL. The relay states are updated in EEPROM each time a relay is switched. In the loop function, handle the web server requests and push button inputs. This allows manual control of the relays using push buttons with the states saved in EEPROM. Now let's test the project. Power up the ESP32 and connect to the Wi-Fi hotspot. Open a web browser and enter the IP address 192.168.4.1. The login page will appear, requiring authentication. After logging in, you will see buttons to toggle each relay. Clicking on a button will switch the corresponding relay on or off, and the state will persist even after a power cycle. Similarly, pressing a physical push button will toggle the respective relay and update the state in EEPROM. This project provides a simple yet powerful way to control electrical appliances using an ESP32-based web server. It includes features like authentication for security, EEPROM for persistence, and manual button control for reliability. In future enhancements, you can integrate MQTT for cloud-based control or add mobile app compatibility. If you found this tutorial helpful, hit the like button and subscribe for more IoT and electronics projects. See you in the next video.